Should I just? All right. Good evening, everyone, and welcome to Group's 2 Senior Design Project Proposal, Final Project Proposal. I'd like to start off by introducing all the group members. Jacob Brady was the Mechanical Design Engineer. Amar Preet Nagra, our Electronics Design Engineer. Ben Morrison, Microcontroller and Software Engineer. And myself, Omar Shabai, RF Design Engineer. And we'll all go through our different parts and explain what we've done. A little about the project as a whole. We needed to build an automated pill dispenser that had the capacity of dispensing 4 different types of pills, and ours handles up to 27 pills of each kind. We also needed a user-friendly interface so that the user can input through the keypad all the times, the different times that they wanted their different pills to be dispensed at different times of the day, and how many pills per dose and all that stuff. We also needed a way to communicate to the user, to tell them, notify them whenever the pill was dispensed, or if they're running short on pills, any warnings or stuff like that. And that was done using a one-way RF communication system. One of the specifications we had in mind is to make it as small and as cheap as possible. And hopefully we were able to do that. Our target customers mainly would be senior citizens, use in nursing homes, and also use by regular people at home, just taking their medicine or taking any vitamins or whatever pills they take. I'll move on, hand it over to Jacob Brady to talk about the mechanical design.
For doing the mechanical part, one thing I had to do was do the physical structure that's going to hold all the compartments, and the other was the motors and what's going to drive and make the pills actually dispense. This is our box. It's 17 by 17 by 17 inch cube. It has 4 round dishes that sit on top, and each dish is about 7 inches in diameter, and each dish will hold 27 pills. And those dishes need to rotate to dispense the pills. Up in the upper right hand corner is the actual dish, and these are the different slots that the pills sit in, and then we have the motor. For the number 1, that's going to be the actual pill dish that holds all the pills, and then the number 2 is a plastic piece that sits on the bottom side where the black part is a cutout. So every time that cutout lines up with the hole, it's going to allow the pill to fall out. This is kind of how it works. The first one is, the black part is a hole, and so all the whites are the pills. So whenever it rotates once, then the red, there's no pill there anymore because it's empty, and then so on and so on until all the pills have been dispensed. There's a side view of it. The top parts, this is our pill dishes, and they collect to the center, and then it goes down to a collecting tube that can be removed, and they can take the pills from there. This is the front view, where you have also 2, so it ends up being 4, and they all line up into the middle to dispense into the cup. This is a picture of it. This one's kind of hard to see, but here's the actual chute that the pills fall down into, and then all of them collect into a center one that leads down to the cup. For the motors, I wanted to use something that had a lot of torque that's going to be able to turn these. Also wanted something that moved really slow so we could really keep track of it, and because I wasn't real sure on how the microcontroller is going to work with it on stopping. And so I got 12 volt DC motors. They're gearhead motors, 3,000:1 ratio, so they spin pretty slow, about 2 RPMs at 12 volts, which is around what I was looking for. And then the gear that I'm using is just a 1-inch, 28-inch pitch nylon gear with a set screw to hold it in place. I use micro switches for a feedback control and also for safety switches. For the feedback control, it's kind of hard to see, there are tabs that are lined up with the hole slots, and every time that it moves, it will click the switch, and it sends a feedback to the microcontroller telling it to stop the motor because the holes have lined up. And so that's how we know every single time that it's going to line up that the pills are being dispensed. We also used it for A safety mechanism, this is on the side of the box where when the lid is open, it shuts all the power off to all the motors, so there won't be any way that someone can get their hand in there and get it ripped off or anything, because they are pretty torquey motors. This is another piece. This is probably one of my most important pieces of it. It's just a piece of plastic that's a 1/4 inch thick. There is a lip that goes around it, and this sits in the center of the pill dishes. This is what helps hold the dish in place so it's completely centered and it doesn't get off track. It also allows me to mount the switch and the motor to this, and then it's bolted into the middle. So during testing, because I wasn't sure on, after it tells the microcontroller to shut off the power, how much longer that motor is going to continue to move a little bit after the power is shut off. So since I'm able to pivot that, I can move and adjust the motors and the switches so the slots are lined up. And then this is just a top side view of it, and you can see where the switch is, and these are all the pegs that line up with the slots. And at the end of our presentation, we'll have a video that will show the switch working and the pills dispensing at the same time. This is my cost sheet for the pill dishes. I needed 4 of them. The total is about $60. For each gearhead motor, they're around $24 a piece, so it comes to about $96. And for the material, it's around $20 to $30 for that. And then I needed 4 nylon gears for each motor, or 1 gear for each motor, came to 4. That was $12. And then I need 6 switches. We have 1 switch per pill dish, 1 for the safety, opening the lid, and then we have 1 for the cup removal, which will be explained later. And so my total was $197 for the mechanical part. And I'll turn it over to Amna Breed.
How you guys doing?
Well,
I'm over pretty not very.
we have to.
Oh, okay, sorry.